Have you ever wondered how a football stadium is built? Those gigantic engineering feats capable of gathering tens of thousands of people in a single location. It's not just about cement, steel, and stands, but projects that combine architectural design, cutting-edge technology, and months or even years of coordinated work. There are more than 30,000 football stadiums across the globe, although only around 400 meet the most demanding international standards, such as those set by FIFA to be considered first-class venues. The origin of stadiums dates back to the early years of football's expansion in England in the 19th century. Initially, fields were simply playing fields delimited by wooden fences, whose purpose was to control the entry of spectators. With the unstoppable growth of the sport, spaces began to transform, with improvised stands and, gradually, permanent stands emerging. One of the most iconic examples from that era is Hampden Park in Scotland, opened in 1903, which for decades was the largest stadium in the world. In England, another historic icon was the Old Wembley, built in 1923, famous for its twin towers and its initial capacity of 127,000. By the second half of the 20th century, stadium construction began to spread across the globe, incorporating improved infrastructure and greater capacity. Brazil's Maracanã, inaugurated in 1950 for the World Cup, marked an era. With space for more than 200,000 spectators, it became a symbol of the power of football in Latin America. Over the years, stadiums have not only grown in size, but also in technology. Improvements have been incorporated to optimize the fan experience and facilitate match broadcasting. In recent decades, the trend has focused on building multifunctional stadiums, designed not only for matches, but also for concerts, cultural events, and shows of all kinds. Examples of this new era are the Allianz Arena in Munich, with its colorfully illuminated facade, or the renovated Santiago Bernabéu in Madrid, which includes retractable turf and a unique technological system. The construction of a modern stadium begins long before the first stone is laid. It all begins in the design and planning phase, where architects and engineers collaborate to shape a project that must be functional, resilient, and visually striking. Before any construction project begins, a feasibility study is conducted to assess whether the project is economically, technically, and legally feasible. This study considers factors such as land selection cost estimation, environmental and social impact. Once the project receives the green light, the architects draw up detailed plans: seating layout, field location, roof design, entrances, locker rooms, VIP areas, press boxes, and emergency exits. Aesthetic elements representing the city or the home team are also included. Structural engineers, for their part, calculate the type of materials needed, primarily steel and concrete, and verify that the design can withstand the weight of tens of thousands of people, as well as possible earthquakes or strong winds. Once the plans have been approved and the project is given the green light, one of the most delicate and fundamental stages of the entire construction process begins: site preparation. Although it may seem like a preliminary step, it is actually the invisible foundation upon which the entire stadium will rest, and therefore typically requires several months of continuous work. This is where heavy machinery such as excavators, bulldozers, cranes, and graders come into play, transforming an irregular space into a stable surface, suitable for supporting a structure of enormous dimensions. The first step involves clearing the site, demolishing any existing buildings, removing debris, and ensuring that no remains remain that could compromise the base. Essential public services such as drinking water pipes, sewage systems, electrical, gas, and telecommunications lines are then rerouted or relocated, as these infrastructures cannot remain beneath the foundations. Soil leveling is another critical aspect, as it ensures that the entire surface is perfectly balanced. To achieve this, laser-assisted surveying technologies and GPS systems are used to detect even minimal height differences. Furthermore, depending on the quality of the soil, it is sometimes necessary to reinforce it through compaction techniques, cement injections, or the placement of layers of gravel and sand to ensure the ground's strength. When the design includes underground spaces, such as multi-level parking, access tunnels for players and technical staff, loading and unloading areas, or sophisticated retractable turf systems, deep excavations are carried out, requiring highly precise calculations. These excavations must be accompanied by drainage and earth containment systems, as an error at this stage could lead to water seepage, ground displacement, or even compromise the stability of the entire project in the future. Therefore, each step is carried out under the strict supervision of geotechnical engineers, who verify that the ground offers optimal conditions to support the weight of thousands of tons of steel, concrete, and, most importantly, tens of thousands of people who will thrill to every match in the future. With the ground leveled and conditioned, one of the most important phases of construction begins, laying the foundations, the invisible support that will guarantee the stadium's stability and safety for decades. This stage determines whether the structure will be able to withstand not only the structure's own weight, but also the dynamic load generated by tens of thousands of fans jumping and moving in unison during a match. Depending on the geological characteristics of the terrain, a choice can be made between a thick, reinforced concrete slab or deep piles that penetrate more than 20 meters underground, transferring the loads to much firmer soil strata. The process includes strength tests, compaction analysis, and load trials to ensure that each foundation meets the highest safety standards. Once this foundation is consolidated, construction begins on the structural skeleton, composed of large columns and beams that begin to give the stadium its shape. It is at this stage that the spaces that will later house the stands, ramps, circulation corridors, and main entrances are defined. Thousands of tons of high-strength steel are used for this, carefully assembled using bolted joints with large bolts, a technique that not only guarantees strength, but also facilitates future modifications, expansions, or repairs without the need to dismantle large sections. This metal frame, combined with reinforced concrete, not only ensures the stability of the complex, but also allows for the creation of imposing architectural designs, floating roofs, curved decks, and angled stands that offer perfect visibility from any seat. The structure is ultimately the vital skeleton of the stadium, enabling the architects' and engineers' vision to be transformed into a solid and functional reality, capable of withstanding the passage of time and the demands of thousands of sporting and cultural events. In today's stadiums, a roof is indispensable. Not only does it protect fans from the sun or rain, but it also ensures that events aren't disrupted by the weather. Some roofs are retractable, adding impressive technical complexity. To give you an idea, a roof of this size can use up to 10,000 tons of steel, equivalent to the weight of more than 50 Boeing 747s. In addition, the cover also plays a key role in maintaining the turf, helping to keep it in optimal playing condition. The stands, where the fans will be seated, are then built. They are designed in sections, with special attention paid to the angle of inclination so that every spectator has a good view of the field, regardless of which row they sit in. Visibility is one of the most studied aspects by architects, since a poorly calculated angle can ruin the experience for thousands of people. While progress is being made on the main structure, another area of work is gaining prominence. The development of the stadium's internal areas, spaces that go far beyond the field and the stands, and are essential for the functioning and comfort of players, technical staff, press, and fans. These include fully equipped locker rooms for players and referees, administrative offices, press rooms with live streaming technology, VIP areas and private boxes offering luxury experiences, restaurants and retail spaces that transform the stadium into an entertainment center, as well as spacious and strategically distributed restrooms to avoid excessive wait times. At the same time, everything is designed with universal accessibility in mind, with ramps, elevators, adapted signage, and guidance systems that allow anyone, regardless of their mobility, to move around independently. Modern stadiums also incorporate technological innovations aimed at ensuring security and smooth access, such as biometric sensors that regulate public entry, high-definition surveillance cameras, digitalized access controls, and precisely arranged emergency exits, ensuring that each match or event can be enjoyed in comfort, order, and above all, safety. The fan experience is crucial, which is why giant high-definition screens, advanced LED lighting, surround sound, and high-speed internet access are installed so attendees can order food from their seats or watch real-time replays. Regarding the stadium's lighting system, FIFA requires minimum levels of 500 lux for official matches, although in tournaments like the World Cup, the figure rises to 2,000 lux. This is achieved by installing hundreds of LED spotlights on towers and the roof. A single match can consume more than 25,000 kilowatts of energy, equivalent to the monthly bill of nearly 100 households. That's why more and more stadiums are incorporating energy-efficient and renewable energy technologies. Many believe that the turf is grown directly in the stadium, but it's actually produced in specialized farms, where every detail of its growth is controlled. Once ready, it's cut into rolls or sheets and laid on the field with millimeter precision. In some stadiums, such as the Bernabéu, a retractable system is used, allowing the turf to be stored in a hypogeum beneath the stadium. There, it receives artificial light, temperature and humidity control, and even CO2 injection to optimize photosynthesis. This system not only keeps the turf in perfect condition, but also frees up field space for concerts or large events. In the final stretch, the seats are installed, designed to withstand years of intense use without losing comfort. Many stadiums use them to create patterns or figures representing the home club. The final touches of paint, signage and aesthetic finishes are being applied. Once everything is complete, operational tests are conducted with friendly matches organized to verify access, lighting, sound and security before the official opening. In this way, after a process that can take several years involving architects, engineers, workers, technicians and specialists of all kinds, the dream of a new stadium becomes a reality. We're talking about millions of hours of planning and construction, meticulous structural calculations, exhaustive safety testing, and the application of technologies that ensure comfort and spectacularity in every corner. All of this requires investments that easily exceed $1 billion, reflecting not only the magnitude of the project, but also the cultural, social and economic importance that football plays in the lives of millions of people. And in the end, when the doors open for the first time, the stadium is no longer just steel, concrete and glass. It is transformed into a true sporting temple, a space capable of drawing crowds, provoking unforgettable emotions, and marking the history of a city and those who visit it.